Assalamu alaikum and welcome. Uh, Dumelang, Goeienaand, and hello to South Africa and the world. Guys, you are tuned into the Qurtuba Online Academy. I'm your host and presenter, Mr. K from the K-Way Institute here in South Africa. We're shooting live here from our studios here at Hilaal TV in Rivonia, Johannesburg. And guys, tonight is a live show. We got a bumper episode. Tonight is probably one of the most important shows that we got for you, grade 12s. You know, you are writing tomorrow. So today's show is the night before you write your final exam. So tonight is like the night. Tonight is the night to Dala Maths. I know grade 11, grade 12, you're not sleeping tonight, right? There is no way you are going to bed tonight. Tonight you are working. You are cracking the, or burning the midnight oil, as they say. We just came back from a workshop from 5 o'clock right through until 8 o'clock. We are live in studio here at 9:30. I ain't sleeping. We're going back online with our learners till 2:30 tomorrow morning. So you're not going to sleep tonight. You are going to be working. You're going to be cracking every humanly possible scenario that you can in mathematics. So I'd just like to say a warm welcome to everybody, and let's get cracking with the show. No sleep tonight, guys. No sleep tonight. Let's get started. We start Bismillahir Rahmanir Rahim, in the name of God. We always praise Allah in the name of God, the most gracious and most merciful, that has allowed us today to stand here in front and talk to the whole country. Now we've got millions of viewers, millions of grade 12s ready for action for tomorrow. Tomorrow you are meeting your Moses. Let's get started. Now guys, some people sent me some questions here online. Let's see, guys. Let's see what are the questions here. So the first question that came out here. Now, my online learners, those learners that were online with me earlier on, right, today, remember we're still going back. 12 p.m. tonight, or 12 a.m. We're pushing till 12, till 2:30 a.m. Right, no sleep, no sleep. Let's get started. The first question that came through here, let's see here. It says, let me just make sure that my screen doesn't tilt. So, prove that. Let's check this one out. Prove that x plus y plus z forms, that's a z, forms a geometric series if log x plus log y plus log z. That's a z. I'm putting a line so we don't confuse it with a 2. That's a z. Let's just make that a z properly. Right? I just put a line through the value so you don't confuse it with a 2. Right. Forms an arithmetic series. Forms an arithmetic series. Now guys, tonight is not the night to play games. You are writing in less than 12 hours. You would probably be finished with your math exam, and some of you may never see math again in your life. Some of you are saying, thank God. Right, forms an geometric series. Okay, let's go. And this here is worth 5 marks. So let's see. Onliners, as well as those people who are watching the show right now, let's see if you can crack this one. Let's see if you can crack this one. Now, those of you that did with me earlier online, we did a question where we had 1 over a plus b plus 1 over 2b plus 1 over b minus c. I know that one killed you. It destroyed you. It destroyed me too. I won't lie. But don't worry. This one is not as hectic. What you need to know is you need to know your log laws. Forms an arithmetic series. So come grade 12s, I hope you are sitting. I hope you're taking this down. I don't even know from which past paper this one came. Somebody just dumped it here in my WhatsApp, and we're busy cracking it now with you live on TV. Okay, so don't worry. This is the first segment out of 3 segments. We're pushing through till 11 p.m. tonight. I'm going to try and do a little bit of everything for you. Okay, so let's get started. Prove x plus y plus z forms a geometric. That means the first thing we need to do is prove that it's got a common ratio. Now, in order for it to have a common ratio for geometric, we know T3 over T2 equals T2 over T1. By now, I don't need to be teaching you the formulas. Grade 12s, you know you are writing tomorrow. Okay, so let's go. What's T3? Z over Y must equal to Y over X. We need to prove that. We need to prove that. So we need to get it to look like that. So how are we going to do it, guys? How are we going to do it? Here we start with this. They give you a condition. They give you a condition. So we start always with the condition. Start with the condition and manipulate it to make it look like the other one. So let's get started. So in your answer, question, answer. Let's go. Log x plus log y. That's an x. That's an x. Plus log y plus log z. Let's see. They say, if that forms an arithmetic series. So in arithmetic, we know T3 minus T2. T3 minus T2 must equal to T2 minus T1. Right? Your common difference formula. Right? We're doing it together, guys. I hope you're all watching, all our 200, 300 learners that were with us there online. I hope you guys are following us now and you're writing it there. Let's go. Let's go. You are tuned to the Qurtuba Online Academy show, the best show in South Africa. Let's go. You are writing tomorrow. So what is T3? Term 3, log Z, minus term 2, log Y, is equal to term 2, log Y, minus term 1, log X. Now usually a grade 12 here is going to get stuck. Usually a grade 12 now you're going to get bombed. But if you know your log laws, you won't have a problem. What are your log laws? And I know most of you, most of the schools, I'm not saying all, most of the schools haven't taught you the log laws. And this is the exam question. How are you going to do it if you see it in tomorrow's paper? Now the log law is if you minus, listen, if you don't know the log law for this, listen to me now carefully. If you got a minus, you divide these two. Log is the opposite of exponents. I'm going to show you the exponential and log graph. We're going to be doing it today as well. You need to know it. It's coming out tomorrow in your paper. And the inverse function. So we're going to be doing different scenarios. You need to be paying attention to me. Tonight, I put on my serious face. This is what separates the men from the boys for tomorrow's paper. Okay, so let's go. You know, grade 12s. Now you need to listen to me. Put down your pens. Just listen. Follow me. You know in exponents, né? You know in exponents, I say ne. You know, we Joburg people, we say na. We say ne. Cape Town people say na. Azad. Okay, anyway, let's just go, please. My mind is with numbers. Today my mind is gone. Let's go. You know from exponents, grade 12s, listen. You know from exponents, when you multiply and bases are the same, you add the powers. For log is the inverse. When you subtract and bases are the same, you divide. So look what happens now. Look what happens. Your bases are the same. You know, there's it. 10, 10. When you don't have a base, you know it's base 10. Right? I'm checking stars right now. I'm just seeing numbers everywhere, bruh. Let's go. So what we're doing now, when you minus, when you subtract, you divide. So watch what happens. You got log. Your bases are the same, so you divide. Because you subtract, you divide. So it's Z over Y is equal to log, on this side here, what are you going to have? Y over X to base 10. Now, when you got a single log equal, you know when you needed to solve a log, you attach the log, you attach the log. So if two logs are on the same side with the same basis, you can cancel the logs. So this is what we do. This is what we do. We cancel the log, we cancel the log. Boom! There's our answer. Z over Y equals Y over X. Right? We cancel. Isn't that equal to that? Therefore, right? So prove that X, Y, and Z. So you're going to say, therefore, X plus Y plus Z in geometric is equal to Z over Y plus Y over Z. And there we go. And you've proved it. Right? We've proved that X plus Y plus Z forms a geometric series if log X plus log Y plus log Z forms an arithmetic series. So please learn this one. Learn this one. Very, very, very important for your exams. Right? Learn your log laws. So you might be asking the question, if we subtracted, we divided. So obviously the opposite also applies. If you add, you multiply the logs. Just to show you, to teach you a little bit about the log laws. There's the number 065-863-1440, the number on the screen. Send all your questions. Inshallah, I hope I have enough time. I'd love to sit with you guys the entire night. I'll sit with you till you write tomorrow's paper also. Immaterial, but we can only do what we can in a little time that we have. So you know what they say in English? If I could, I would, but I can't, so I won't. Let's go. Let's go. Next level, guys. Next level tonight. Next level questions tonight. So let's take that thing out. Let's see the next question. Okay, so as I was getting back to that, I said if you subtract. So watch this. Here's your log law. So if you had log 2, let's make this log 2 12 minus log 2 6. You know what is that equal to? Log 2 12 over 6. And that is going to equal to log 2. What is 12 divided by 6? 2. And log of any number to its own base is 1. Log, remember that and write that down. Take down these notes. These are just hints for tomorrow's paper. You know your normal run-of-your-mill questions. I'm just doing all the things that could catch you in your exam. Log of any number to its own base is 1. Whew, let's go. So if you subtract, you divide. So what if this was added? Now you might ask, but Mr. K, what happens now if this was added? What happens if that was added? So when it's added, you multiply. So 12 times 6, which is equal to log 272. Just so that you know, 12 times 6 is 72. There's nothing further you can do with that. So you just leave it just like that. Okay, so enough with logs. So just remember, when you subtract, you divide. When you add, you multiply. Okay, the reverse of exponents. Okay, let's go on to the next question here. Let's go on to the next question. Let's see. Okay, somebody asked me. I think it was Zahra that sent this question. I'm going to give you something similar in sequences and series. Right. If 3,27 rewrite. Let's put it this way. I'm going to do something similar. Rewrite 3,27 recurring as a common fraction, using series formula. Using series formula. Now it's worth 6 marks. Right? The higher order question for grade 12s only, not grade 11s. Grade 11s, you don't do this at all. Right? I was speaking to somebody this morning and they said, you know what, I might be understanding nothing in mathematics, but I'm loving the show. So guys, whether you're a parent, whether you're a child, whether you're a teacher, makes no difference. Hope you guys are enjoying the show. Stay tuned to Hilaal TV, channel 347. Okay, let's see. Come on, grade 12s. What are you going to do with that? If a question like this comes out in tomorrow's paper, what are you going to do with this? After this, I'm going to do one with convergent and with a convergent series. Right? It also came out. Somebody sent it to me here. We're going to do that one. I think that will take us to our first ad break. When we come back, I'm going to do a little bit of functions for you as well. Right? And then we'll hit some calculus. We'll see what we can do right through until 11 o'clock. So stay tuned. Stay tuned. Okay. I know I'm talking fast. And I know I'm talking a lot. But you need to focus. You need to pay attention. I know my eyes are a bit this small here. I'm seeing stars now. But don't worry, we know what's cutting. Let's go. Let's go. Whew. I talk a lot, ne? Maybe I must keep quiet a little bit. Grade 12s, crack it, boss. Crack it. Crack it. You know what to do here. Let's do it. Must I help you? All right. That's what I'm here. That's what I get paid to do, right? Okay, so we start off with 3,27. Recurring. This is equal to 3 plus. Now, pay attention. That 27 is recurring. So we know that's going to go on to infinity. It's going to be 27, 27, 27, 27, and it's going to continue to infinity. And the minute you see infinity, that's when we're going to be using series formula. Okay, so what's after the bracket here, guys? We got 2 dots. So it's 27 over. 2 dots is 2 zeros. 2 dots is 2 zeros. So it's 100. Plus the next 2 is 1, 2, 3, 4 dots. So it's 27 over 4 zeros. 1, 2, 3, 4 zeros. So it's 110,027 over 6 zeros. 1, 2, 3, 4, 5, 6 million. Plus going on to infinity. Are you seeing something happening here? Are you seeing something happening here? That is a geometric series after the brackets. That is a geometric series after the brackets. Let's go. Let's just find out. Control room, how are we doing with time, boss? We doing good? How many minutes left? Okay, excellent. 10 minutes. There we go. Control room giving us the 10-minute signal. Let's go. Let's crack this. So this is 3 plus. Right, so we got A equals. Your first, remember this is a geometric. Your first term here, A is 27 over 100. Your common ratio is that divided by that. So what do we have? 27 over 10,000 divided by 27 over 100. So R is equal to, if you divide that times 100 over 27 times 100 over 27, 2 zeros will cancel. 27 cancels. You're left with 1 over 100. You're left with 1 over 100. So you're left with 1 over 100. Check it on your calculator. And we know, and this is infinity, R is less than 1 but greater than minus 1. 1 over 100 is less than 1, greater than minus 1. So therefore, it converges. Guys, they're going to ask you tomorrow. I promise you. They're going to definitely ask you about a convergent series. And how do we know whether something is convergent or divergent? We look at R. What do we look at? We look at R. If R is a fraction, if R is less than 1, between 1 and minus 1, it converges. It comes together. Okay? So now, what is our formula? So this is equal to 3 plus. Now we know S to infinity is equal to A over 1 minus R. You agree with that? You all agree with that? That is your formula. Please, in the exam, you don't have time. Learn your formulas tonight. I'm going to tell you something now nice after we're done here. I'm going to recap for you all your formulas. Right? We're going to go through. I'm going to show you guys something to make you warm tomorrow. I'm going to show you how we're going to mind map everything. Right? And we're going to remember all our formulas. We're not even going to look at our formula sheet. Okay. So now this is equal to 3 plus. Okay, what's A? A is 27 over 100 divided by 1 minus. What's R? 1 over 100. So let's go. Use your calculator. 3 plus. We got 27 over 100 divided by 100 over 100 minus 1 over 100 is 99 over 100. So this is equal to 3 plus. What do I have? I got 27 over 100 multiplied by 100 over 99. Isn't? We multiply by its reciprocal. Correct? Of course we correct. 100 and 100 cancels out. 9 goes into there 3 times. 9 goes into there 11 times. There we go. I'm moving up to the side. Your answer is 3 plus 3 times 1 is 3 over 1 times 11 is 11. 3 plus 3 over 11 is 3 and 3 11s. Boom. Boom. That's your final answer, boss. 3,27 recurring as a common fraction. There we go. That's your common fraction. And that's your final answer. Now, as the show here is designed to ensure that you are ready for tomorrow, put your pens down. That's what I'm going to ask you for. Put your pens down. Let's see, for tomorrow's paper, what do you need to know? You need to know all your algebra, right? You need to know your simultaneous equations. You need to know exponents, and you need to know your higher order algebra. In fact, I might even do 1 or 2 higher algebra questions here just for everybody. Then sequences and series. Know your formula. Know your formula. Sequences broken up into 2 parts. arithmetic, geometric. Arithmetic, Tn equals a plus n minus 1 times d. I know I'm not talking Japanese. Those of you watching it for the first time, the grade 12s know exactly what I'm talking about. Arithmetic and geometric. Arithmetic, Tn equals a plus n minus 1 times d. It's got a common difference. T3 over T2 equals T2 over T1. If they tell you the 10th term, I'm going to show you a higher order question just now. If they tell you the 10th term, you know it's a plus 9d. If they tell you the 100th term, a plus 99d. Geometric, Tn equals ar to the power n minus 1, got a common ratio. Yes, you're right. Term 3 over term 2 equals term 2 over term 1. And we know term 10 is ar to the power 9. You got to know it. Series broken up into two parts. Series broken up into two parts. What is it? Don't tell me arithmetic and geometric. Wrong, you will fail. Series is broken up into two parts. Finite, one that ends. Infinite, one that doesn't end. Finite is broken up into two parts. Arithmetic and geometric. Arithmetic broken up into two parts. You know what I'm talking about, grade 12. I'm not talking Japanese here. Right? Arithmetic and geometric. Arithmetic is broken up into two parts. One where the last term is given. One where the last term is not given. Learn the proof. It's bookwork. So Sn equals n over 2 into a plus l if your last term is given. Or Sn equals n over 2 into 2a plus n minus 1 times d if your last term is not given. Geometric. You can look at it, but you need to know it. Otherwise, you're going to fail tomorrow. You're going to open up now. Geometric. Sn for finite. We're still under finite. One that ends. Calculate r. If r is a fraction, if r is less than 1 but greater than minus 1, Sn equals a into r, 1 minus r to the power n over 1 minus r. Or if r is greater than 1, if r is a whole number, Sn equals a into r to the power n minus 1 over r minus 1. Geometric. Geometric. Infinite. Infinity is only geometric, not arithmetic. And that's broken up into two parts. Conversion and diversion. One where r is a fraction, one where r is a whole number. If r is a fraction, you know s to infinity equals a over 1 minus r. That's what we did in the previous one. That's the formula we applied. How many minutes? We got 2 minutes left. Right, you're listening to me and I'm wrapping up the first segment. And then we know we got where r is greater than 1. S to infinity equals a over r minus 1. So just before break, just before we cut for break, grade 12s, I know you're sitting, you're burning the midnight oil. There's a question here. Here's a question that I want you to do. Let's see. Here, this one came in. Let's see. Okay. I don't know. I've got no idea who the next question came in from. But I'm going to leave it for you for break. When we get back from break, I'm going to do the memo for you. I'd love to sit the entire night with you guys, working out item for item, question for question, topic for topic. Guys, you tune to the Qurtuba Online Academy show. I'm your host, I'm your presenter, Mr. K, K-Way Institute. Hola. Eta. Right, let's go. The first three terms, right, they tell you the first three terms. Let's take this one quickly before we go for break. The first three terms of a geometric sequence. There we go. Or series. Let's say, they say series. And they give us 5 into 1 minus p over 3 plus 10 over, oh, that's the first two terms, sorry, the first two terms. They only give us two terms. Into 1 minus p over 3 all squared plus ... Find the values of p for which it converges. Find the value or values of p for which the series converges. Let's see, how much time do we have? Converges. Right. And we will, let's leave this one here. Find the value or values of p if the series converges, and find the sum to infinity. Find the sum to infinity if p equals, give me a number, 2. There we go. We're going for break. See you guys. Stay tuned. Qurtuba Online Academy, K-Way Institute. See you guys after the break. And we're back. And we're back. I hope you guys enjoyed that little bit of a ad break. And we're back to the Qurtuba online show with me, your host and presenter, Mr. K from the K-Way Institute here in SA. Right, no sleep. This is a live show. You know what they say, no sleep for the wicked. Here we go. Let's go. The first one, find the values of P for which it converges. So let's do the answer here. The answer to question number 1. This is the way. I'm going to give you a bit of a template. I'm going to give you how to unpack it in your exam. So for it to converge, because that's what the question asks you, for it to converge, we know R must be less than 1 but greater than -1. So we need to calculate what is R. Right, so R is equal to that term divided by that term. Right, remember we're only dealing with geometric. Infinity only deals with geometric. So they didn't even need to tell you it's geometric. You know infinity only deals with geometric. Let's go. So R is equal to 10 into 1 minus P over 3 all squared divided by 5 into 1 minus P over 3 to the power 1. Right? That term divided by that term. Guys, are you all following? Are you all following? I hope you did that during the break. So now, that's your R. That's your R. So whether you do it on the side or you do it here, no problem. No problem. So now, I just do it on the side. I like to do it on the side. I'll only put in P here because they say find the values of P for which it converges. So let's work it out here. What is R? R is equal to, like I said, you want to put it here, you want to put this whole thing here in the middle, no problem. 10 divided by 5 is how much? 2. 1 minus P squared, 1 minus P over 3 all squared, divided by 1 minus P to the power 1 over 3. The 2 minus 1 is 1. So that means 1 minus P over 3. That's R, right? So that means instead of R here, we're going to put 2 into, let's go, 2 into 1 minus P over 3 less than 1 greater than -1. There we go. I hope you're doing it. You can do it exactly the way that I'm answering it here. You can unpack it in your exam tomorrow, should you get something like this. They love these questions. So you've been working through your past papers, right? You should know what to do now. Now we divide by 2. Remember, I need to get rid of this 2 first. I need to get rid of this 2. So I divide this side by 2. I divide that by 2. I divide that by 2. 2 and 2 will cancel. What am I left with? 1 minus P over 3 less than a half but greater than -1/2. Now let's multiply everything by 3. So that minus 3 over 2, right? Less than 1 minus P less than a half times 3 is 3 over 2. Let's continue, right? So now we got minus 3 over 2. I'm copying and pasting. I'm just putting it here on the side. Less than 1 minus P less than 3 over 2. Now take the 1. Now remember the 1. Let's choose a different color. Let's choose a different color. The number 1 here goes over on both sides. So minus 3 over 2, minus 1 less than minus P less than 3 over 2 plus 1 goes on to the other side as -1. So minus 3 over 2, minus 2 over 2, I'm just doing it because I don't have a calculator here, less than minus P less than, this is 1.5 minus 1. 1.5 minus 1 is a half. Okay, minus 3 over 2, minus 2 over 2, the number 1 is 2 over 2. So that gives you minus 5 over 2, less than minus P, less than a half. Right? We want P. For which values of P? So we divide by -1. We divide by -1. We divide by -1. What am I left with? Negative and negative cancels. 5 over 2. Because we're dividing by a negative, the inequality changes over. Please make sure. Please make sure. Please make sure. Right? And divide by -1. There we go. There we go. That's your final answer. And you know what you can write after this? So P is greater. How do you read this? I don't know. Do I need to teach grade 12s how to read this inequality at this point in the year? How do you read this inequality? Come on, Mr. Pen. Open up. I don't have time for you. Right. So now what do we have here? Right. How do you read it? You read first to the right, then you read to the left. So P greater than -1/2. In fact, it can be written like this, minus a half up to 5 over 2, like that. So it's between minus a half and 5 over 2. These are your values of P. But you don't leave it like that. You don't leave it like that. You say now for these values, it will converge. For all other values, for all other value or values of P, the series diverges. So for these values, guys, between here, it will converge. Outside of this, so let's say -1, -2 going to negative infinity. This is 2.5 going to positive infinity. It will diverge. So for any other values of P, it will diverge. For those values of P, it will converge. Let me just see. I hope I'm not standing in your way. I hope you're not standing in your, I'm not standing in your way. I'm going to take a seat for a couple of seconds for you to take all this down. There we go. You got to know this for tomorrow. Ladies and gentlemen, boys and girls, we now need to do the next part. We need to do the next part. Find the sum to infinity if P equals 2. Come on, S to infinity, sum to infinity if P equals 2. Let's do it together. Right, so this is the answer for the first part, right? We're now going into the second part. Deep breath. Let's go. We're going underwater again. So let's go. I hope you've taken this down. Please, you need to write. Where I went to the side, you will just continue in your paper going down. Yeah, it's a lot of work, but it's easy. It's not difficult. Right, so let's go to the next part here. Find the sum to infinity if P equals 2. So let's answer question number 2. Let's answer question number 2. Right, there's your R. You found R. You found R. I'm going to leave R here because we're going to be using it here. What is S to infinity? By now you know for convergent, guys, what is S to infinity? Sum to infinity equals A over 1 minus R. So let's go. S to infinity is equal to A over 1 minus R. Why? Because it converges. And that's what they want you to find. So S to infinity, the sum to infinity is A. 5. That's a 5. Yay. Even my handwriting is going crazy today. 5 into 1 minus P over 3, right? Divided by 1 minus your common ratio. There's your ratio. Let's put it like this. Let's put it in brackets. And that is going to be 2 into 1 minus P over 3. There we go. Right, so A is your first term over 1 minus A is your first term over 1 minus R. By now you should know this. Grade 12, you're writing on this tomorrow. Right. Let's go. If P equals 2, so that means S to infinity is equal to 5 into 1 minus 2. P is equal to 2. P is equal to 2 over 3. Right? All over 1 minus. Now we're going to go. I can multiply this out 2 times. So let's put a 2 here. Let's put a 2. So we got 2. So let's leave it here. 2 into 1 minus 2 all over 3. I'm using square brackets. Let's continue. S to infinity is equal to 5 into 1 minus 2 is minus 1 over 3 all over 1 minus your fraction. 2 times, okay, let's go 2 into, let's do our brackets first. Remember, BODMAS. Try your brackets first. If you're getting confused, just think BODMAS. And whenever we're doing, and please guys, tomorrow, don't mess up in your algebra. I beg you, don't mess up in your algebra. Okay? Make sure your signs, one sign out and you are goner in tomorrow's paper. Let's go again. Brackets, you always start from your inside out, not from your outside in. So 1 minus 2 minus 1 over 3. Let's go. S to infinity is equal to 5 times minus 1 over 3. That's 5 over 1. Numerator times numerator, denominator times denominator. Minus 5 over 3. All over 1 minus. And in your brackets, you got 2. That's 2 over 1. So that will give you minus 2 over 3. Whoa, we still don't have space. Yo, check this one out, brah. Minus 5 over 3. All over 1. Negative times negative is positive. 2 over 3. I'm moving up to the you know who says our president, our old president. So S to infinity. Aish! This one, man. This one, man. 5 over 3 over. 1 is 3 over 3. So 3 over 3 plus 2 over 3 is 5 over 3. Shoo, we're finally coming to the answer, bruh. So now let's go. Let's go. Let's go. Can you guys feel the electricity? I know you guys are working. You guys are boosting tonight. You're boosting on numbers. Multiplied by 3 over 5. There we go. Multiplied by 3 over 5. 3 and 3, 5 and 5. 5 and 5, 3 and 3. Boom, your answer is -1. Take it down. We started here, continued there, and then I had to move up. So let me just show you now. If you guys just joined the show, where did we start? That was part number 1. That was part number 1. We moved over to the side because we didn't have space. That was part number 2. You'll continue down, and there's your final answer. There's your final answer. That's part number 3. And there we go. Yes, like, check that out. That one there for a couple of marks, couple of good few marks in tomorrow's paper. Okay, you also know that they could ask you in sequences and series the sum of 50 terms. And yeah, they could give you something like that in tomorrow's paper too. You're going to do one like that, where they ask you for the sum of 50 terms. Yeah, you want to do it? Let's do it. Come. Come, bring and come. You know what they say? In Durban fellas say, bring and come. Right, Mr. K, hurry, you spoil the curry. Let's not spoil the curry tonight. Let's go. Right, so you took it down. Step number 1, step number 2, step number 3, take a screenshot. Remember I can't even tell you the show will be uploaded tomorrow. You'll be done with your exam. Okay, so there we go. Guys, welcome to the Qurtuba online show. The Qurtuba online show. Let's do now the sum of 50 terms. Come on. And then I'm going to finish up with this. I'm tired of sequences and series. Aren't you guys tired? The last show that we did, the last live show, I did the higher order quadratic number pattern. So if you missed the show, go to the YouTube handle, go to Hilaal.tv or go to Hilaal TV on YouTube and just go to all the previous shows, right? Watch all of them if you still don't know the higher order quadratic pattern. Okay, so let's go. So they tell you here, let's make up one. Let's say 5 plus 2 plus 8 plus 4 plus 11 plus 8 plus ... Question number 1. Extend by 2 terms. Extend by 2 terms if the series if the series behaves in the same pattern. Question number 2. Find the sum of the first 50 terms. Find the sum of the first 50 terms. Right. After this, in fact, I might give you, you know which one we can do after this, if you stay tuned to the show. Sigma. We do sigma with 5,000 and we do sigma with 4,999. Right. So stay tuned. We're going to be doing that one just now. Whew. Hectic, ne? Yeah. Let's go. Extend by 2 terms. Come, grade 12s. Come, grade 12s. You're writing tomorrow. Let's see how you guys deal with this one here. Right? After this, I'm going to do one sigma question. Only one. And then I think we might almost be to break or whatever. But then I'm going to do some functions. I need to show you guys. Please, you're getting tested on the inverse of a parabola. Tomorrow, 100% you're getting tested on that. You're also getting tested on the exponential and the log function. So stay tuned. We're going to be doing that after this. Okay, so let's go. So we got extend by 2 terms, find the sum of the first 50 terms. I wish I had like 3 hours with you guys now, and we could do so much more. Okay, so let's extend by 2 terms. I hope by now you've realized, I hope you've realized that every alternate term is arithmetic. and every alternate term here is geometric. So let's go in our arithmetic pattern. 5 plus 3 is 8, plus 3 is 11, plus 3 is 14. There we go. And the next one is 2 times 2. So this one is plus 3. That's plus 3, and that's times 2. So 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So that's 14. Your next term here is 16. Right, 14 plus. This is plus. Right, so you extend by 2 terms, 14 and 16. Those are your next 2 terms. Right, find the sum of the first 50 terms. Now we got 2 separate series. One is arithmetic, one is geometric. Right, so we're going to do, now remember, we need to find the sum of the first 50 terms. But I have 2 series. So I'm going to find S25 in the first, I'm going to find S25 in the second, and we're going to add them up. So let's find out arithmetic, S25 in arithmetic, S25 in geometric. Let's add this up. Let's add it. So now we know the sum of the first 50 terms. So Sn equals n over 2 into 2a plus n minus 1 times d. Your last term is not given. So S25 is equal to 25 over 2 into 2. A is 5 plus n minus 1. 25 minus 1 is 24. Your common difference is 3. And there we go. S25 is equal to 25 over 2 into 2 times 5 is 10 plus 24 times 3, 24, 48, 72. So this will give me S25 is equal to 25 over 2 into 82. And that will give me S25 is equal to 2 into 2 once, 2 into 4, 82, 41 times. 41 times 25, what's it? 950. I don't know. Check your calculators. Take your calculators out. Let's go to our calculators. Okay. Let's do that. And we need to get out of there. Okay, let's go here and let's go fx 991. And what's it? 950? I don't know. Let's work it out. 25 times 41. Hey, 1025. 1025. 1025. So S25 in your arithmetic is 1025. S25 in your geometric. R is greater than 1. R is equal to 2. R is equal to 2. So Sn equals A into R to the power n minus 1 over R minus 1. S25. Woo, I don't know. I think we're going to get a big number here. What's A? 2 into. What's your common ratio? Also 2. So let's do it in brackets. So let's say 2 to the power n to the power 25 minus 1 all over 2 minus 1. I think this is going to be a big number. I think she's going to be a big number. So 2 into 2 to the power 25. Yo. Let's go down. Minus 1. Close brackets. Over 1. 2 minus 1 is 1, so I'm going to leave that, right? Yo, yeah, it is. She's a big number. What is the number? The number is 671088862. So therefore, S50 is equal to 1025 plus 6710882. And here we go, 1025. Boom, 671098887. And there we go. That is our final answer. Let's see, so you've taken this one down. I hope you are taking it down. I'm just going through here quickly. There's a question while you're taking this one down. There's a nice question that I've got here as well for you. Let's see, where is she? Where is the question? So let's go. So we got that, and there is the question. Okay, so you've taken this one down. There was also another nice question I came across just now. We're going to be doing. In fact, maybe we can do that one first. So let's go here to our chats. Let's see what they've sent us. Let's see what they've sent us. And here goes. Consider the series sine 30 plus cos squared 60 plus x to the power 0 over 2 to the power 3. Find the value of s to infinity minus s5. It's the last one we're going to do in sequences and series. Right, we've just been told, yo, I tell you, time flies when we are motoring. Okay, unfortunately, I can't do so much, guys. Let's do this one. We've got 5 minutes left before our next ad break, and that is bringing us to the end of segment 2. This is bringing us to the end of segment 2. Right. In fact, I'm gonna focus on a little bit of functions in segment 3 and a little bit of calculus. So let's see how much we can get done. Okay. So they tell us that consider the series sine 30 degrees. So they tell you, whoa, we didn't even take that out. So let's take all this out. Let's take all that out. We don't need that. We don't need that. Okay, let's just go. Let's just put this again. Let's go. Bismillah. Rahim. Rahim. There we go. Let's go. Let's crack this. Bismillah. They tell you consider sine 30 degrees. Sine 30 plus cos squared 60 plus x to the power 0 over 2 to the power 3 plus dot, 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 dot. Question number 1. Let's write the question. Oh, no, only one question. Calculate the value. Calculate the value of s to infinity minus s5. Right, I don't know how many marks this one is. I can't even see it on here. I can't even read it on there on the screenshot that they've sent me now on the group. So guys, 065 863 1440 is the number to send the questions to. Okay, so let's do this, guys. Grade 12s, here's the question. Consider they've given you this. They've given you guys this. You want to try this one out? Came out of a past paper. Remember, guys, let me tell you something about mathematics. It's not about doing every humanly possible scenario. But you must be exposed. You must know what to do in each part, right? I mean, it's the first time I'm seeing this question. Never saw this question before in my life. We're working through it here together, and I'm answering it as if we are writing the paper tomorrow. But you need to know your work. Really, for tomorrow, burn the midnight oil, know all your formulas. Remember, sequences as series, functions. Know your parabola, know your straight line, know your hyperbola. Hyperbola would shift in asymptotes, exponential. Know your inverse functions. Know your log graphs. Know that. Then finance. Finance, you guys know. Again, if you missed any of our previous episodes, go back. You need to know all the different types of finance that's going to come out. Future value, present value, balance outstanding on a loan, trade-in of an asset, immediate payment, deferred payment, final payment. Know all of them. I'm telling you, 15 marks there, it's going to come out. Calculus, first principles, derivative, differentiation, equations of tangents to graphs, you need to know. Sketching and determining equations of cubic graphs, optimization. And the last one, probability. Last year's probability, and you got to know factorials and fundamental counting principle. We did that in our last live show. So please, if you missed it tonight, just go back. Go to YouTube, check it out. We've done all the templates for you. Tonight, we're just getting you ready for tomorrow's paper, inshallah. Right, let's just hear. Control room, how many seconds we've got? Cut, and it's time for break. Do this one. I'll catch you after the break. And we're back. And we're back, and we're back, and we're back. Right. Some of you have sent us comments here. Never been so excited to write maths tomorrow. I hope you know your stuff. I hope you know your stuff. You know, it's the most confident ones maths has got. Don't be too proud. Maths, maths has got a tendency to break you at your knees. Make sure you know your stuff for tomorrow. Okay, guys, let's get back to the show. Remember, you guys are going to, you're not sleeping. I'm also not sleeping. I promise you, after I was telling the learners online earlier that you writing the paper tomorrow, the minute you finish the paper, I go to my local school, I get the paper. I also write the paper after that. I want to see a 3-hour paper with what I've taught you through all these episodes and whatever we've done, right? Whether every type that we got, I'm going to try and score about 90 to 95% in tomorrow's paper. And my target is 1 hour. I need to finish that 3-hour paper in 1 hour. 2 hours to sit with a higher order question. If I get it, I get it. If I don't get it, so what? I got 90%. I need to check that. So that's my excitement. That's my boost for tomorrow. Right, enough chit chat. Let's get back to the show, brah. Right, let's go. We got some lekker questions also that came out. I got that killer question. I know people have been asking me about that big optimization question with a parabola and a straight line. We're going to crack that one after this, right? I might give you guys something lekker to do, a good algebra question, and then we're going to crack that optimization. This is the last segment for today's show, guys. Last segment. Okay, what is sine 30? So we've got that to infinity. Calculate sum to infinity minus S5. So sum to infinity, the minute they told you sum to infinity, you know it is geometric. The minute they asked you that, you know it's geometric, and we know we need to calculate R. Oh, what is sine 30? Sine 30 is a half plus cos 60 is sine 30, which is a half. Because sine 60 is root 3 over 2, your special angles, right? So cos 60 is a half squared plus x to the 0 is 1 over 2 cubed is 8 to infinity. So this is equal to, let's expand this. This is half plus 1 squared is 1 over 2 squared is 4 plus 1 over 8 plus dot, dot, dot. You know your next term is going to be 1 over 16, 1 over 32, 1 over 64, 1 over 128, 1 over 256, 1 over 512, 1 over 1024. You know what I'm talking about. You know. Don't pretend like you don't know. Yeah, it's that time of the night, 22:11, and we're going crazy on numbers here. Right, so now what do we have? We got A is equal to a half. R is equal to also a half. That divided by that, right? And we know R is less than 1 greater than minus 1, so therefore it must converge. Right, so now we're going to find out S to infinity. So now S to infinity minus S5. So I'm going to do it like this. S to infinity for convergent is A over 1 minus R. Minus the sum of 5 terms. The sum of 5 terms. Now you know what you can do. Because it's a small number. Okay, let's just do it as A into 1. R is a half. 1 minus R to the power n over 1 minus R. Right, let's do it like that. Let's do it. In fact, you could have, if you wanted to. It was only 5, right? It's only 5 terms. It's not S15 or S50. Big ones, you can use the formula. Otherwise, like I said, you know this here is 1 over 16, 1 over 32, 1 over 64. So 1, 2, 3, 4, 5. All we have to do is just add that up if you want. So what's A? A is your first term, half, over 1 minus, what's your common ratio? Is also a half. Minus, let's add all this up. Come on, man, I don't want to use the formula. Do you want to use the formula? I don't want to. So 1 over 2 plus 1 over 4 plus 1 over 8. I'm in no mood to use the formula. So let's go to our calculator. Let's put a fraction. 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus 1 over 32. I was lazy. I'll be honest with you, I was lazy. I don't want to use that formula. It was 1 over 32. You get 0,96875. 0,96875. 0,96875. Right. Now, a half divided by a half. A half divided by a half. Right? 1 minus a half is half. So a half divided by half is 1. Right. So I'm just going to use my hand here. So that's 1 minus 0,96875. And your final answer will equal to 1 minus. So let's go there. Let's say 1 minus 0,988. No, 96. 9. Okay. 9. 6875. 6875. 0,03125. 0,03125. There we go. If we use a over 1 binary, you should be getting exactly. But I think you understand the process. I'm not even going to go back to check. You know exactly what to do. You know what to do. I'm not going to even check whether the answer is right. I think I'm 99.9% sure that I'm right. But you know the process. Sum to infinity minus S5. Whatever your values are, put it in, check your algebra is correct, and make sure you get the right answer. Somebody asked me during the break, okay, let's give you that other algebra question that they gave us. Where was that question? Where was that algebra question, right? Goodness. Okay, don't worry about it. Somebody asked me during the break, how do we sketch the inverse of a parabola? Right, they asked it here on the group. So let's go. I'm taking this out. Please, you need to know this, the parabola. So let's talk about the parabola a little bit because it's very important and I feel that it's exceptionally important that we do it tonight. Right. You know the opposite, the inverse of a log is an exponential. But you also know, right, so let's go. Let's say f of x is equal to 3x. Let's make it a third x squared. There we go. That's a parabola. Question number 1. Question number 1. And let's say for x greater than or equal to 0. Right. I want f of minus 1x. Right. I want f of minus 1x. Question number 2. F of minus 1x. Question number 2. Is f of minus 1x a function y? And how will you restrict the domain of f? How will you restrict the domain of f so that f of minus 1 becomes a function? There we go. Mark allocation for the first one. Let's give you 3 marks for that, 2 marks for that, 2 marks for that. So 3 and 2 is 5 and 2, 7 marks in total. Okay, very important. That's what's given. That's your question in your exam. That's your answer. Now they give you a third x squared. They're going to play around with your parabola values, right? Okay, in fact, you know what we should have done? We should have said question number 1, sketch f of x. And made this question number 2, question number 3, question number 4, sketch f of minus 1x. Right, so sketch f of minus 1x. Yeah, let's give you 3 marks there, 2 marks there, 2 marks there. Let's give you another 2 marks here. Come on. Sketch f of minus 1x for another 2 marks. Total. 3 plus 2 is 7, 8, 9, 10, 11 marks. 11 marks. Sketch f of x. Oh, why did I go and put f of minus 1x? Sketch f of x. What was that? Okay, is f of minus 1x a function? How will you restrict the domain? And you could have even give the equation of f of minus 1x, right? Okay, find f of minus 1x. You know what? Let's do this. Sorry about that. Is give f of minus 1x. Question number 2, I want the equation of f of minus 1x. That's question number 2. Question number 3. Question number 4. Question number 5. And let's add on. So sketch f of minus 1x for 3 marks. The equation 2 marks. 3, 2, 5, 6, 7, 8, 9. Yeah, I'm still on 11. What's happening tonight? 3 and 2 is 5. 5, 6, 7, 8, 9, 10, 11. Okay, right, let's go. Let's answer it. Sketch f of x. Now, guys, the learner who asked me now on the group, how do we know that it's a parabola? Obviously, it's x squared, right? Now, you know that your y-intercept is 0. So all we're going to do now, we're going to do that. What you can do, you can, if you want to draw it accurately, you know what the shape of the, you can put x equal 1, x equal 2, x equal minus 1, x equal minus 2. After you put in your values, obviously, you're going to get a value here. So you're going to get a graph going up that way, and you're going to have a graph going up that way. And there is graph f, right? So for x, you can put 1, 2, minus 1, minus 2. Just substitute it in for x. You'll get your corresponding y values, and that will be your coordinates. Just join the dots, and you've got a positive parabola. Now, it's positive. It's a smiling face, because this is positive, so it's a smiling face. But they tell you, read your restriction. So this is an entire graph. If no restriction is given, it's plus minus, right? If no restriction is given, it's plus minus. You know why plus minus? Do you know why plus minus? What is the square root of 9? Just come on, let's just forget about this now. If I ask you what's the square root of 9, don't tell me 3. It's plus or minus 3. Remember, when we're finding a square root of a number, it's plus or minus. Here's it. We're just sketching it. Right? Positive and negative, plus minus. Right? The square root of 4 is not 2. It's plus minus 2. Square root of 25 is not 5. Okay, you know where I'm going with that. Right? So here we go. But they say for x greater than 0. For x greater than 0. There's your restriction. So we erase this part. And there we go. That's sketch f of x. There we go. We got our first 3 marks for it. The equation, let's do question number 2. The equation of f of minus 1x. F of minus 1. So f of minus 1 is the inverse. Right. Now be careful. Be careful. Now watch. What is the inverse of 1 over 3? It's 3 over 1. What's the inverse? So, and then we're going to have x. And what is the inverse of square? It's the square root. But be careful. They're telling us for the positive part of it. So you only put plus. You don't put plus minus. Although in your square root, you normally have plus minus. Whenever, remember I said the square root of 9 is equal to plus minus 3? But they gave us a restriction for x greater than 0. So we only leave the plus. We don't put in the minus. Now, this number outside tells me the restriction. The sign inside, that positive sign, tells me whether my original is positive or negative. My original is positive, so I leave this as positive. If this was negative, then that would be negative. But don't tell me now, but sir, you can't get a square root of a negative. It's not negative. If this was negative 3, if x is negative, negative times negative is a positive, you'll still have a square root of a positive number. Okay? You with me? We vibing? Grade 12? We vibing? We vibing. Good. So there we go. That's your answer. F of minus 1x is equal to the square root of 3x. That's it. That's your inverse. Now, is f of minus 1x a function? Right now, let's see. F of minus 1. Okay, in fact, this one here, we shouldn't have even asked you the last one because it's not a whole graph. Remember a whole graph. I'm actually going to take out that question number 4 because a whole graph will look like that. And then because it's pointing to the positive y, the inverse of this will be pointing to the positive x. That means that will go like that. And this graph here, this graph, the inverse, f of minus 1, is not a function. Why? If it was a full graph. So in fact, like I said, let's take out. Again, they can ask you, I'm taking out this question here because we've already restricted it for you. It's not a function. This one is not a function. Why is it not a function? Why is it not a function? Because it's a one-to-many relation. For one x value, it has many y values. One x value, it's got two y values, so it's not a function. This is not a function. Now let's look at that one. Is f of minus 1 in this case a function? Now look here. Now you want to know how to draw this, right? So I'm going to write f of minus 1 here. We got f of minus 1x is equal to plus the square root of plus 3x. Right. How do we sketch that? Right, I'm erasing this. Please remember this. The sign outside tells you your restriction, whether x is greater than or equal to 0 or x is less than or equal to 0. Right? The restriction of the original. Inside tells me whether my original graph is positive or negative. Okay, so I'm just moving over here. I'm taking this out here. I'm taking that out. That was just for explanation purposes. Let's go back in here, guys. Right. Now you know. Yeah, I got all my pens here. Right, watch here. We know that the positive parabola went like that. So that means the positive inverse would go like that. Yes or no? That's f of minus 1. But remember, our original is restricted to only the positive part. So take all this out. Take all that out. And now we don't want the negative. Remember, this is the positive part. That's the negative. That's above your x-axis. That is below your x-axis. What do we want? Do we want positive or do we want negative? We want the positive, guys. Why? Because x is greater than or equal to 0. So I only want that part. So I delete that part. And that, you don't need to put that in. And this is f of minus 1. And there we go. So whenever you see a graph starting at 0 going like this, you know it's the inverse of a parabola. Write this down. How will I phrase it? If the graph starts at 0 and it's going in a parabolic shape, right? If it's starting at 0, you know that that's an inverse of a parabola. Write it down. It's an inverse of a parabola with a restricted domain. So this is an inverse. This graph here is an inverse of a parabola with a restricted domain. Know that. Know that. It's going to be tested tomorrow. Don't ask me how I know. I didn't get wahi. I didn't get revelation. Don't worry. But I just got a hunch. And usually my hunches are right. Inshallah. Okay. So there we go. So is this a function? So if we had to sketch it, there's it. We sketched it. Is this a function? Yes. This is a function. Yes. It's a function. Why is it a function? Because it's a one-to-one relation. For one x, the whole thing is not a function. But with the restricted domain is a function. Why? Because it's a one-to-one relation. Okay, and there we go. There we go. I hope that clarified. Remember, you're getting tested on this tomorrow. Remember, you are getting tested on this tomorrow. Okay, let's look at the next question. We've just been informed we got about 7 minutes left. Let's leave you with a cracker. Let's leave you with a cracker of a question. Right. We're going into calculus optimization, right? Onliners, those of you who are online with us now, I hope you're enjoying the show. Guys, South Africa, hope you're loving the show. Unfortunately, I can't do probability now and finance in the show. We have done it in the previous shows, okay? But yeah, onliners, I'll see you at 12 o'clock tonight. We go on from 12 o'clock right through until 2:30 tomorrow morning. And you know, I know you guys are boosting there. No sleep, bruh. No sleep. Know your work. Know your work. May Allah make it easy for you people tomorrow. My heart goes out to you. Like I said, I wish I could sit with you right till your paper. Inshallah, don't worry. Remember, Saturday, yeah, we've got paper 2 coming up as well. So, guys, follow our social media handles. Follow Facebook. Follow me on Facebook. Follow us on YouTube. Follow Qurtuba online and Hilaal TV. They will keep you up to date with all the latest happenings that is going on. Remember, this is not the end. We still got paper 2, guys. We still got paper 2 on Monday to write. And that is your double and compound angle trigs. Okay, so they give you this one here. I know you guys have seen this one. Inshallah, I hope I have enough time today to finish this on the show, right? So this is your question. They give you a parabola like that. And they give you a lighthouse going on the top. They tell you that is T. They tell you that is Q. Then they then give you a line going, how do we draw this, guys? So we got a line going from here. We got a dotted line going right up. I hope my line is straight and it touches here. Okay, it's supposed to be a straight line. Right, I'm trying my best. I'm trying my best to get in a straight line here. That's a straight, whoa, it looks a bit curvy, but it's a straight line. They give you that, they give you this. They tell you that's point S. They tell you that's angle theta. They give you a point where the 2 meet. They call that point P. That point here is point Q. Please don't confuse the 2 points. And they call that graph H. So a soldier, so they talk about a soldier S. So there's it, Mr. Soldier. Mr. Soldier S. He shoots at a fixed target TP or TQ at the crest of the highest point of a hill. So he shoots straight here, right? From here, that's where he is, and he's shooting straight there to the top. The height of the hill is represented, so the height of the hill is represented by h of x equals minus x squared plus 4x minus 3 for x less than or equal to 3 but greater than or equal to 1. P is just a point on the hill. Right, so can you picture this? Write an expression for the gradient of the hill. Question number 1, write an expression for the gradient of the hill, in terms of x, Don't worry, I'm going to move out of the way just now. And number 2, what is the smallest angle theta that the soldier can aim to shoot the target? So, find angle theta. The smallest angle theta. And they say smallest angle theta. I'm thinking, guys, 1 mark and 6 marks. Mark allocation, 1 mark, 6 marks. Total mark 7. I know you're smiling. Grade 12s, I know you're smiling. Control room, give us a time there. How much time do we have for the rest of our segment today? Because I need to crack this one here on TV. 4 minutes left. 4 minutes left, guys. Take this one down. There's it. Should I move out of the way? No. You guys are good there. Okay. Right. Write an expression for the gradient of the hill in terms of x for 1 mark. Maybe you can't see that clearly. Right. I'm just putting this here. This here is 1 mark. This is 1 mark. And this one here is 6 marks. So there we go, guys. There we go. Let's check the question. Let's read the question. Let's go. Guys, how much time have we got? I think we got about 2 to 3 minutes left. Let's crack this one. Let's dial this one properly, like a boss. Right. Let's do number 1. Right. Write an expression of the gradient. The minute they say gradient, What are they talking about? Derivative. So that means h dash x, h prime x is equal to minus 2x plus 4. Don't ask me how I got that. You know. We find the derivative. Power rule. Power rule. So there's it. That's why it was only 1 mark. The answer to question number 2. Okay. Okay. Let's go. Find angle theta. Now listen to me. Listen to me. We've got a straight line here, right? We got a straight line, and it's touching this graph here. So what do we know? The two graphs are equal at that point. So we got the parabola, and we got a straight line. So we know, right, y is equal to mx for the straight line, plus c. What's c? C is 0, because it goes through here, so I don't put c. Right, y is equal to mx, equation number 1. What is our other graph? Our other graph is y equals minus x squared plus 4x minus 3. At the point of contact, the two graphs are equal. So now you're going to say minus x squared plus 4x minus 3 is equal to, that's equation number 2, is equal to mx. Minus x squared plus 4x, right? Minus mx minus 3 equals 0. Minus x squared plus, let's take out our highest common factor there as x. Let's take out x. What am I left with? 4 minus m minus 3 is equal to 0. Minus x squared plus 4 minus m x minus 3 equals 0. How do I get rid of x's? Divorce them. Right. No, I'm just joking. Talak. Right. How do you get rid of, right, so delta is equal to b squared minus 4ac. This is equal to b squared. B squared. 4 minus m squared minus 4a minus 1. I hope Hilaal TV gives me another minute or two to finish it up, and they don't start screaming at me and telling me, hey, Mr. K, time is up. So let's remove the brackets here. So this is 16. 16 minus 8m plus m squared minus 4 into 3. This is equal to 16 minus 8m plus m squared minus 12. This is equal to m squared minus 8m. 16 minus 12 is 4. Right. Now we know that they are equal. So for equal roots, delta must equal for equal roots. Here we're almost there, guys. Delta must equal to 0. So we got m squared minus 8m plus 4 equals 0. You can use your quadratic formula, or you can use your silver calculators. What do I have? M is equal to, I get two m values. M is equal to 7,46, or m is equal to 0,54. So now we're going to go. They want angle theta. Your angle of inclination. So we know m is equal to 0,54. That's the gradient. So now we go to analytics. Tan theta is equal to the m of your line, 0,54. Theta is equal to shift tan 0,54, 28,19, which is approximately 28,2 degrees. So the soldier needs to stand at an angle of 28,2 degrees, and boom, he will hit his target, bruh. 1.5 hours, it flew, ne? You want more? Sorry, ne? Next time. Assalamu alaikum. Welcome. Jazakallah, everybody. I hope you guys enjoyed the show. This is our time out. Guys, I hope you enjoyed. Good luck. Inshallah, may Allah subhanahu wa ta'ala make it easy for all our grade 12s tomorrow. You know, we're not putting in 10%. We're not putting in 100%. We're putting in 500% of our effort. We're literally breaking our backs to make sure that you, the matriculant, get your best marks and you make something. You become positive contributors to South Africa. South Africa needs you. Grade 12s, I'm your host, presenter, out of studio, last show for 2022. Hope you guys enjoyed all our shows. Remember, Qurtuba Online Academy, the best online academy in the world. From me, Mr. K, Kway Institute, Assalamu alaikum wa rahmatullahi wa barakatuh.